Hi everyone, my name's Jamie. I post under my own name, James Donaghy. I'm from Scotland. So today I want to offer you a lecture about the Apollo missions as the kind of focal point of it. But really, it's a lecture that I was thinking of giving the title, How the Apollo Programme Saved the Military Industrial Elite. But it might easily be called How Apollo Spoiled Science for Generations. So I'm just going to do this off the cuff. I don't have any notes. I'm going to be moving. Can I move up and down a wee bit? This is going to be quite a long lecture, I'm afraid. So I need to get a little bit of yeah. This is quite good. I'm using the Galaxy S10 here. It's my daily driver. It's a great phone. I'm really excited about the way technology is advancing so fast. Unlike what we had before the invention of the semiconductor, the valves and everything we had before that were great, but they just had nowhere near the power, the computing power that we have today, and the applications that were achievable in 1969 were really pitiful, you know, compared to what we have today. The ordinary citizen can have in their hand. You know, it just wasn't available to all the great and the good of ages gone past, including the 1970s. Okay, little segue there. Yeah, so how did Apollo save face for the military industrial elite? And brackets, spoiled some good movies too, end of brackets. Okay, let me go straight to the movies. I'm thinking particularly of Forbidden Planet. I don't know if any of you guys know that movie, but it was like the flagship sci-fi movie for MGM, and it came out somewhere around 62 when they were thinking about Apollo, slightly before that actually, late 50s I think it was. Anyway, fantastic movie, well worth watching, a real icon in cinematic history, movie filmmaking history. So the reason that it spoiled it is probably because there's a perfectly good scene that any good sci-fi buff will have enjoyed. So the starship that our heroes are travelling on is in hyperdrive, and it's going to sort of decelerate and come back out of hyperdrive into a star system relatively near Earth, probably, in terms of the whole cosmos or the galaxy even. Anyway, when they come in for landing, as it were, into this star system, solar system of that star, yeah, there's a bit of ambiguity whether when you say star system you talk about constellations or, you know, anyway, an asterism as it's called, I think. But no, they're coming into the planets and the star itself in for a landing on one of the planets, and the captain rebukes the navigator because they've come in too close, and the navigator says, no, we're quite far out, it'll be fine. And the hull thermal overload warning system alarm kicks in, you know, and the captain's like, I told you so. You know, he says, get the ship behind the shadow of that first planet. So, I mean, we don't know exactly how far out they are from the star, but or how big the star is, but we can guess, you know, that they're not a million miles away from 1 AU, 1 astronomical unit, or Earth's distance away from the sun out. They're not far off from that. You know, they're somewhere around that Goldilocks zone. Anyway, so, yeah. that whole scene was clipped. So that's an outtake that was never used in the final cut. You say, well, why was that never used? And this is before Apollo has actually been, announced. Well, if anybody's familiar with any of my other videos, or at least my one other video, it's not had that many views. It's getting off of 5,000. It's a lot for me, but I'm not a YouTuber. Yeah, the reason that would have been cut, as far as my narrative goes, is because there was a real problem with heat issues for the veracity of the Apollo claims. So when you look at the Apollo craft, the heat, thermal insulation, the thermal energy protection is inadequate. There isn't a lot there. All other low Earth orbit missions have used shade in some form or another. Even if you just count the shade of being in orbit, because half the time you're in the Earth's shadow, so you've got half the time to recuperate. It's only 45 minutes that you're seeing sunlight at a time, whereas Apollo was in the sunshine all the time for 8 days. So there's that. Actually, it's 2 days on the moon, 3 days there, 3 days back. So was it not more like? Yeah, that is 8 days. Okay. So, I mean, like I say, I posted a video about this, and I've had about 1,500 comments where people are making various remarks, but some of them are really, most of that's comprised of conversations that I've had with people who have gone backwards and forwards with me over the science of heat. And, so to my mind, I've really opened a can of worms here, I mean, maybe I've got the whole story wrong, but people have certainly presented some erroneous views on heat transfer. My background is partly, I'm an electrician, so as such, I've had to learn the regulations, not off by heart, because there are a lot of them, but I've had to learn the basic principles that govern the regulations, and that's basically all about heat. So, I feel that I'm pretty well positioned, apart from the fact that I did study science, not just at high school, but a little bit at college too. And yeah, so I totally understand where people are picking up erroneous ideas, because it now is clear to me, I've got some friends who are physics teachers, and it's clear to me that heat transfer is something that isn't taught correctly in schools. So when you get to about 3rd or 4th year in your physics class in Scotland, so that's usually the age of about 14 or 15, whatever it is in your school system, you get taught about heat transfer, and you get taught like there's 3 choices, there's convection, conduction and radiation. And people are spoon-fed this stuff, and often they don't think about it, and that's their, that's their chapter and verse for them. That's like quoting directly from the gospel when they come out with this line. But if you think about it, really there is only one form of heat transfer, which is radiative heat transfer. So convection and conduction are actually accelerated forms of radiative heat transfer, and radiative just means that it comes from the hot spot and goes to the cold spot, and it'll always do that in a kind of spherical way, which is where you get radiates from. So I mean, it doesn't really explain much about how heat is transferred. you know, you still have to ask, well, how does it do the radiative heat transfer? What's the mechanism here? And really, I don't know. I know that thermal energy is transferred from one object to another in various different ways, depending on the energy level. So if it's extremely hot, extremely energetic, then you might be getting transferred by X-ray or gamma ray. But normally, the heat we get from our benign star up there is through infrared radiation, and that's the stuff that you can feel directly on your skin when you maybe get a little bit burned on it, or even just, you know, it's a sunny day and you can feel the heat, the sun on your face. That's infrared light hitting you. So, but that isn't the only, and people get confused about it because it is kind of complicated, because that infrared light is hitting the air around you, and some of it's getting absorbed. I mean, so like I say, you know, the stuff that you feel hitting your face is coming directly from the sun, but all around you the air's warm, the ground's warm, and that's all sort of more indirect, diffused kind of heating. Like I say, it's all radiative. And the thing about convective heat transfer, which not everybody always realises, is that that's quite dependent on gravity. You know, so no gravity, no convective heat transfer. But really, I don't want to go into all that just now today. All I want to say is that, you know, I made some mistakes on my earlier video about making claims about the higher up you go, the hotter it gets. What I meant to say was, the nearer the sun you go, the hotter it gets, and whether you're, you know, rising up 5, 10, 30 miles from the Earth's surface, it's not necessarily making you any closer to the sun. You know, you might start off on the ground nearer to the sun than what you will be by the time you go up 30 miles, you know, because the Earth is travelling, the sun's travelling too, and the distance it's travelled will probably have a much bigger effect on your distance from the sun than if you consider the time it would take you to get up 30 miles. Anyway, put that aside. Obviously it gets colder when you go up through the troposphere, which is the area of the atmosphere that we live in, the low down area where all the life is, or at least all the known life. Yeah, so, you know, and so Apollo claimed that, or NASA claimed that Apollo was cooled by turning, in a manoeuvre they called the thermal protective manoeuvre. And basically, the craft turned about 3 times an hour in the sun, and the idea of this was to even out the hull temperature. But, you know, that isn't really going to work for you if you're, say, sitting in an Apollo type vessel on the beach under the noon sun. You know, turning the thing round 3 times isn't going to be like, you know, an hour, isn't going to be a good replacement for something like air conditioning or, you know, a parasol or something like that. So, getting a little bit off point here. I just wanted to go over a couple of the reasons why, a couple of the things that have been exposed, a couple of errors that have been exposed in people's thinking about heat transfer. You know, and how they should have known as physics students, and just people carefully examining the narrative that the craft would have had heat control issues, and it would have had to have some kind of resources to deal with that, and they weren't there. Everything that was on the Apollo vessel is itemized now, you know, for posterity. So every nut and bolt really is counted, and we don't have any parasols, and we don't have any effective thermal insulation. And, you know, even if there had been more of that, you know, you would be talking about quite a thick sort of build-up of insulation to protect that craft over those 8 days of constant, effectively summer solstice sunshine, you know, a perpetual noon summer solstice. It's you know, just doesn't bear thinking about. Anyway, put that aside for a second. Even supposing the Apollo mission was a true account of what actually happened, there's still some huge problems about the whole deal and how people think about it even today. So, you know, there's a great feeling for Apollo, and the last thing I want to do is be a negative person. You know, I know people love it, the idea, the man that walked on the moon, the man walked on the moon, the man's greatest achievement and all that. Well, you know, there's plenty to rejoice about where technology has got man. We have achieved things it seems every decade. There's something else that people said would never happen, and it comes to pass through technological advancement. But Apollo is not one of those things, and it never was. You know, you had some incredible claims for the things that were done on the Apollo mission, specifically LOR. I would say that was the most amazing thing, because you had like a little capsule launching off a bigger capsule and, you know, off the moon's surface. And then the crew were able to navigate of that little device, that little vehicle were able to intercept an orbiting vehicle that's going faster than a speeding bullet. And this little ascent stage only weighs 2 tons, and yet it's got the power to rise up 60 miles and accelerate to 4,000 miles an hour, and then intercept this other vehicle that's moving at 4,000 miles an hour. How incredible is that? But from all those claims, we have no legacy. You know, even today, just the one aspect, the soft landing on the moon's surface. Well, we've had a failure of an Israeli mission to match that feat, even with a little robot, you know, a little lander, you know. And the other thing I ask is, why have we not got like little landers on the moon's surface that you know, don't crash when they get there? Why haven't we got more of those? And why aren't they looking around the place with little cameras? I mean, why can't I have an app on my phone that gives me, you know, a chance to take over one of these little buggies for even, you know, a few minutes, or watch somebody else who's got control of it is doing? You know, they're not there. It's like we're not interested, but we are interested. We're very interested, you know. And here's another thing that is a complete aside, but I just want you to appreciate how, you know, you can look at these things for yourself and see maybe a different view of it that you just don't see represented anywhere in the mainstream. So, for example, talk about the dark side of the moon. Now, most people know there isn't a dark side of the moon per se, because although we're tidally locked, the side that's facing away from us gets the sun for as much of the time as the side that's facing us. And sometimes when we look at the side that we can see, it's dark, like the new moon, that phase of the moon. But as people have always noticed, it's not completely dark. You can see something. Well, my point is, that would actually be quite a bright place to be, even when it looks like, you know, we can only see a little crescent, or some people say you can only see the crescent. If you were on the moon at the darkest phase, at the darkest point of the phase, or just on the nighttime side of the moon, it would still be quite bright, especially during what we call the new moon, because in that phase you'd have a full Earth, and the full Earth would be taking up 4 times as much sky as what the moon takes up for us looking at it. And so the albedo of Earth, being water, is actually it's more reflective than the moon, I believe. So the moon albedo is quite low. Obviously, we have the polar caps as well, which would probably be most reflective. But even the land, you know, so that you can see the Earth shine at times on the moon, depending, you know. So I suppose the Earth has different, its albedo changes all the time with the cloud that's in the sky. But yeah, so maybe that would be the cloudiest days on Earth would be the sunniest days on the moon, as it were, or at least the brightest nights on the moon, because that would be the brightest object, or the second brightest object in the sky if you were on the moon, would be the Earth. Anyway, my point is that even apart from the Earth, even the glory of the Milky Way in front of you with the sun on the other side of the planet, if you're on the moon, because that is kind of a planetoid, whatever. But yeah, the stars, the light's coming unfiltered, you know, there's no pollution. So you'll be getting a brighter night sky. There's no cloud at all. So it'd be much brighter than what you get in the Earth. And you'll probably remember from maybe your childhood those very bright moonless starlit nights, which we used to occasionally enjoy. And you still can today, I'm sure, in the dark sky zones, if you're familiar with any of those. Anyway, yeah, we have a few of those around the UK. You know, it's great for the anybody who's interested in astronomy to enjoy the night sky. But yeah, so I'm just trying to demonstrate here how even down in the darkest crater of the moon, you'd still see your hand in front of your face. It would never be like the darkness that we get here in Scotland on a cloudless, overcast night, which out in the hills is considered by some mystic writers to be the only true dark that you're ever going to experience in your life. It's got to be Argyll, it's got to be Scotland. And I can verify that, I can vouch for that as much as anybody. You know, you've been in places where you cannot see your hand right in front of your face like that, and you're looking at it to verify it, you know, and it's true, you can't see anything. And yet somehow you find your way home. Your feet find their way home, I suppose, even without a torch. So, what I'm trying to demonstrate here is that you can think through things for yourself, like I have done with that example, where you can kind of rely on your own judgment. You get to a point where you say, well, I'm convinced about that. And it's going to take a lot for somebody to come along and say, no, it would actually be black out in the moon. You wouldn't see anything. Yeah, it would take a lot for somebody to convince me of that now. And I think you can see why now that I've laid out my case. You may not be so convinced about the heat on orbit for the Apollo crew, how it would be unbearable. And you may even think that the protective thermal role has got some validity. But for me, it's quite clearly demonstrated that, you know, if you do the same thing on a beach, it's not going to cool down a vessel significantly for you, you know, just by turning it 3 times an hour. And also the science of heat tells me that if a vessel on the beach in the summer solstice is too hot for people to climb inside a metal container, then it's going to be too hot for them to climb inside up there. Because the difference between up there and down here is that we have air, and that is a cooling force. So out there, having no air, you do not have that cooling element. And also, the heat is a little bit more intense because you don't have the filter, the heat filter of the atmosphere, which is considered to be something like a third of the true energy. It's 1.36 kilowatts per meter squared is what they call the insolence, or the, you know, the power of the sun hitting an object perpendicular to it. So, you know, if we've got a solar panel and it's facing the sun in the most ideal way, then that area would be achieving that, you'd be harnessing that much power. So for every square meter, it'd be 1.36 kilowatts, which, if that's constant for 8 days, you're going to need something to cool down anything that's out in that's supposed to have life in it. Anyway, I'm going to put that aside for a moment, because what I really wanted to focus on today was how the Apollo missions saved the military-industrial complex elite from losing all credibility. So, okay, let me switch back to my movies in that kind of timeline, the late 50s, early 62. I'm going to go for one more movie, and I think it was called Mission to the Moon. So it's 1962. I've got the year right. It was a Polish movie, so probably quite a big budget. Not as big as Forbidden Planet, nowhere near the special effects and things like that. But the quality of the special effects on Forbidden Planet were the best. Anyway, this not so good. A little bit amateurish. So Mission to the Moon, and you have the crew there in 1962, and I mention this movie because, and there are, you know, a few movies out there from the era on that subject, and I really feel that we're getting kind of prepped for the Apollo missions with some of these movies, especially this one from 1962, where one of the crew turns out to be a survivor, or family of survivors, or family of perished in the concentration camps. And so this is 62 is 17 years after the Second World War ended. Okay. And this crew member has got a grudge against the captain, because it turns out the captain was working for, or he was a serving officer in the German army. So one of his fellows says to him, look, try and get over it. Try and put all that in the past. Let's move on. It's a new world, new age. We're out here in space. Forget about all that. It's just history. And I just feel we're getting prepped here, you know, for what's to come. I may put a link to that film, that movie, below. That's the plan anyway. I will get around to it sometime. So, yeah. And that's what we did get. We got Werner von Braun, who was responsible for making the V2 rockets that bombed so devastatingly Antwerp and London. He used to be a Londoner, you know, so I've always got a grudge against Werner von Braun, because he really terrorised the Londoners. He killed about 2,000 of them with V2s. The Doodlebug, they called it for a while, and it was all hush-hush and secret. You went to talk about it because it was such an enormous success for the German campaign, the Nazi war campaign, German war campaign. They terrorised the people of London, which is exactly what they wanted to do. The V2 was the only bomb that you couldn't hear coming because it was supersonic. So, yeah, people lived in fear of just, you know, being victims of that. Anything else, you know, they had a more of a chance, basically, against it. But with the V2, you were just there 1 minute, and then the next you were gone. And that terrified them. Of course it did, you know. Anyway, this also gets me to a point where, you know, the way von Braun was canonized, basically, by the military-industrial complex elite, and he was so well thought of by a lot of the American people. I mean, he was idolized, but it just totally, you know, the idea that Israel are getting on board with this whole moon landing narrative, which they have done, you know, and NASA's helped them to launch their little failed mission there. It's not something that I can countenance, you know, even from a Gentile point of view, but I just really feel that the Israeli state has betrayed the Jewish people here with this. And I hate the way I'm sounding right now, you know, and I know it's all politics, so you're standing on people's tails all the time, aren't you? But, you know, this is governments we're talking about, and as a rule, governments are generally in the wrong, my experience. I don't mind slagging off governments, you know. Well, what they've done here, the Israeli government has given credence to the whole Apollo mission, which they always did anyway, but now they've really like ramped that up. The 50 years anniversary is coming up, and yeah, in a couple of months. And yeah, this is a real nod to that, and it's homage to the military-industrial complex elite who organised all this and who, you know, benefited from these moon landings. So, yeah, so there was Werner von Braun giving NASA giving the United States his rocket hardware and know-how. You know, the first rockets that NASA tested, they were built with slave labour in Europe. That's how close and interlinked the whole thing is. Werner von Braun was a serving SS officer. Now, okay, you know, he had to do that to survive, you could say. But, you know, Werner von Braun did everything with a bit of swagger and a bit of style, you know. And he never apologised in any kind of public way that I'm aware of. So, anyway, it kind of doesn't matter, because this is 50 years later. If we really apologise for anything, I guess if I don't know about it, then it wasn't that public, because, you know, I've been kind of preoccupied with the history of the Apollo missions. Anyway, so there you are, built with the blood of these people. Werner von Braun was a brilliant slave driver, you know, and literally, like, so it was all slave labour that built the craft, and it was he who was the slave driver. He was the chief. He was always the chief. And when he went to the United States with his 100 German scientist crew, that was still the same way. He was a chief. And when he arrived, the United States did a little ceremony that I've just found out about quite recently, where they took him to Mexico and they made him skip over the border and then back again, and that absolved him of all his past and his war crimes, and made him a legitimate citizen of the United States in the eyes of the law. So yeah, it's just, sorry, it's just treacherous. Well, I'm not apologising. It's the United States government that I'm criticising here. I'm not criticising the people of the United States. I'm criticising the military-industrial elite complex, the mice, you know. So anyway, this is 1962 we're talking about, where, well, obviously that happened after the Second World War, but in 1962, they got John F. Kennedy to announce that he inaugurated the Apollo program in the Rice Stadium under the baking hot sun, and that was a point that came up once or twice in the lecture. John F. Kennedy, in that lecture, mentioned the heat that they would have to face, and what a challenge it would be. What he what he said was that they would have to develop new alloys. They would have to survive temperatures several times higher than anything ever endured before. He then went on to say in the next clause, or the next sentence, the next paragraph, you know, how the heat of re-entry would be thousands of times hotter than the melting point. Well, basically, I'll leave a link to that below, and you can see for yourself. But, you know, some people have said to me, no, when he's talking about temperatures several times higher than anything I've ever endured before, he was talking about re-entry. Well, it clearly wasn't, you know, and I want to thank Thomas Kundera for that, you know, that rebuttal to my analysis of his speech. So this is one of the people from commenting from my previous YouTube video on heat. So let me retrack a bit. Yeah. So there was no new alloys, you know. We didn't get any new alloys. We've got no legacy from Apollo. If you ask NASA, if you look on their website and say, what's the legacy of Apollo? What did we really learn? Then sometimes they'll cite everything, basically every technological advancement that's ever been made. They'll cite the internet, they'll cite satellites. Satellites, for God's sake. Yeah. That's just ridiculous. The truth is that you cannot trace anything back to Apollo. You know, I mean, even if you said Tim Berners-Lee was an Apollo astronaut who spent all his time, you can't do it. You know, if NASA had given us the internet, we'd be paying for it. I'd be paying to upload this and you'd be paying to look at it. You can be damn sure of that. Tim Berners-Lee is disrespected every time somebody says that the Apollo missions resulted in the net. Anyway, well, it just shows you how you can really make factious links. Is that the right word? You can make links to things that have no grounding at all, you know. In reality, everything is connected to everything else. As Voltaire said, the Jesuits can prove anything. So why did John F. Kennedy come out and make this this assertion that he was going to head, you know, he was going to fund this moon mission with the taxpayers' money in 1962? Well, you know, as far as JFK is concerned, I'm sure he was sincere. He was sincere and he meant it. But the people behind him knew that it wasn't going to happen. They absolutely knew it wasn't going to happen. And I say that because they had tried very hard to make it happen. And they failed. And they knew that they'd failed. And they failed in a global way where everybody really knew something was going on. And yet, it's all been forgotten. So let me explain. In 1962, a bomb was launched called Starfish Prime. It was a nuclear bomb, and it was launched in the stratosphere. Now, that is odd in itself to most people who are familiar with nuclear bombs and what they're about. Nuclear bombs are generally considered to be weapons of mass destruction. And it's odd to see somebody using it for a different purpose. We do have nuclear science and we do have radioactive isotopes being used for medicine and all kinds of spectroscopic applications. But nuclear bombs are generally not used for anything apart from destroying people or testing out the potential destructive capacity of a bomb. And because of that, we have three types of nuclear detonation. We have underground, we have surface, and we have we have airbursts. But launching a bomb in the stratosphere isn't aimed at any country or individuals. It's quite detrimental for people generally, because it's introducing a lot of pollutants into the environment. But why is a question that a lot of people didn't answer. When they heard that the government had signed a test ban treaty, or when they hear it today, that in 1962, the United States of America and the Soviet Union signed a nuclear test ban treaty, they don't automatically get the information that the nuclear ban was to do with stratospheric explosions. And then once they do get that, they might assume that, you know, certain reasons why it was done in the stratosphere. What do you think the reason that those bombs were tested in the stratosphere is? Have you ever thought about it? Has that ever occurred to you? Did you know it was going to happen? Did you know it was happening? It happened? Probably not. In 1962, everybody knew it was happening because there had been reports for people who didn't live around the equatorial regions, or even, you know, quite high up in the degrees going, you know, north and south. There had been an incredible light show at night. People were saying they could read the newspapers from the light of the aurora. This was all new. This never happened before. Never happened before in history. Probably never. You know, an absolute first for this planet. What had happened was the Starfish Prime, which was 4 megatons equivalent of dynamite, so a huge explosion. That's like, so a skip is about 8 tons. That's a big skip. So 1,000,000 tons is, what's that, 125,000 skips. So 4 times that. This is basically 500,000, is it? I think that's right. So it's 500,000 skipfuls of dynamite, the equivalent energy of that. And that was only one explosion. It was the biggest one in the program, called Operation Dominic, from a bigger program called Operation Goldfish Bowl. And we're told that the Russian efforts to do exactly this, very similar things, was unrelated, for my money. And this is a different topic, but it does come up once or twice in my research. I can't see how you say they're unrelated. I've no doubt they were sharing data between them. They were doing the same thing. What was the thing they were doing? Were they testing out bombs to see just how to get it exactly, you know, the right flavour and the right constituency to produce exactly the right damage to people and to the planet's surface? No, it wasn't that. It's ridiculous. It just doesn't add up. What it was they were following the advice of Dr. James Van Allen. Van Allen was a really able scientist, and what he had done was map out the magnetism of the planet in a big survey. He was a very apt student of another wonderful scientist, whose name I believe maybe I'll link to down below because I can't remember it just now. And yeah, so the United States Royal Navy were launching Explorer 1, which was a survey rocket. Sputnik had been launched in 1957, and the United States hadn't quite got there with the power of launching satellites, but they were able to launch non-orbital missiles pretty far out. 16 miles was considered then to be like the Kmar line, they call it. That's you in outer space. And they could get they could do a certain amount of travel out further than that without achieving true orbit. So they were going to launch Explorer without any reconnaissance on the, sorry, not reconnaissance, it's reconnaissance, well, reconnaissance will do, reconnaissance on the radioactivity around the planet. The interesting thing about the radioactivity, it kind of tells you what the magnetism is, and that's the thing that Van Allen had been interested in. So, like I say, they had mapped out the magnetism on the planet from pole to pole, and they showed us all the lines of force and the relative strengths of magnetism at every point on the Earth, and we could infer all the bits they'd missed out. You could infer what it was likely to be. So a wonderful resource for scientists to explore with and to use. So when Dr. Van Allen found out they were putting a spacecraft, a rocket, out so far, he wanted to record his magnetic field as much as he could. So he wanted to put a Geiger counter on it with some recording capability and try to do a little map of the magnetism going by the radioactivity. So the more radioactivity you've got, the stronger the magnetic field. So the theory is that the coronal mass ejections or the solar wind, the particles get trapped by the magnetic field. So the stronger the radioactivity, the stronger the magnetic field. So I mean, that's quite easy to follow all that, isn't it? There isn't anything there that is difficult, I don't think. Anyway, that exploded, that rocket, because in 1957 they weren't very good at it. You know, rockets, it was touch and go. And even today we have not just the Israeli rocket smashing on the lunar surface, trying to do a soft touchdown, but even Elon Musk hasn't got a very good record of soft touchdowns. I mean, all praise to him for managing to land heavy vehicles softly on the ground, but you know, we cannot ignore the fact that it doesn't always work out. And the idea that they're going to put a human being on top of one of those rockets anytime soon is ridiculous. That will never happen. People certainly won't pay for that privilege, and it just won't be allowed, you know. That's a long way in the future. That's maybe 30 good, safe, soft touchdowns away from happening, you know, before anyone even gets on the rocket that goes up. Anyway, enough of that for just now. So back to the Explorer 1. Two just disintegrated on launch, I think. No, sorry, one was successful, one did go up with a Geiger counter, but the Geiger counter broke. So the Geiger counter he put on Explorer 1 was kind of an off-the-shelf device that was used for mining, to find out if the mine was too radioactive to go down, you know, it was too hot. So he decided that what had happened was perhaps that the radioactive field had been too strong. You know, that was his feeling about it. So he beefed it up, and he sent a modified Geiger counter up. I think it was like purpose built, and that came back with some very interesting readings. And it showed quite clearly that without going very far up from the Earth's surface, you're encountering lethal radiation. Now, we hear about the Apollo missions, how Dr. Van Allen was co-opted, you know, to find the best path through the radiation to give the astronauts the best chance of survival. But that doesn't actually, that doesn't work, you know. It doesn't fly. That story doesn't fly, because Van Allen said, look, the only chance that you've got is perhaps a polar exit. The problem with a polar exit is that you're doing an orbital ascent. And so you can't really do a polar exit. The best you could do is what they claimed they did, which is, you know, they started off in an equatorial orbit because it's easier to use the rotation of the Earth to get you going. And then they converted that by changing the angle of heading, and you know, got into an orbital orbit. But even in an orbital orbit, you're passing through the equator on every orbit twice. So, and the first layer of radioactivity, and the first layer of magnetic strength of the field, the magnetic field, the first layer of the magnetic field is, you have to do a lot of orbits to clear it, because it starts off at about 1,000 miles. Sorry, it starts off quite soon after you get off Earth, and it lasts for over 1,000 odd miles. And then you get out 20,000 miles, and then you've got a different belt to deal with. And depending on solar activity, apparently you have a third belt as well. We now know, which the Apollo missions, they weren't aware of that, which doesn't really help their story. But like I say, it doesn't matter anyway, because it turns out that the polar caps are quite radioactive as well. So if you're in the industry, as I found out quite recently, on the flight crew, you're only allowed to do so many polar passes during the year, because the radiation is quite high. And I thought, that's odd. I thought that was supposed to be the weakest part, but then I realised that is where the air is the thinnest, the atmosphere is the thinnest, so the least protection. So yeah. So this was a problem for the military industrial complex elite, because they wanted somebody out there, you know, and they wanted somebody out in space. They wanted to conquer space. So all the stuff that you hear where they're telling you, oh, it was a race against the Soviet Union. Yes, well, whether it was a race against the Soviet Union or whether it was just they wanted it, you know, it doesn't matter. They wanted it, and they had to have it. And what Dr. James Van Allen suggested was that it was magnetism that was keeping the radiation in place. So if they could neutralize the magnetism, then they would solve the problem. Now, the whole import of that advice isn't immediately clear to everyone, but people look at Mars today. Scientists say that the reason Mars is barren and lifeless is because it lost its magnetism. And it seems pretty clear that if we lost our magnetism on Earth, we would not have the same protection that traps all that radiation. And certainly high energy UV light would hit Earth without that magnetosphere. So what James Van Allen was presenting then would not be countenanced today. You know, it'd be considered a very dangerous thing. And this is something that people have not woken up to. And it's really time they did. I'd just like to give a little bit of credit to Amy Shearer, who runs a channel called Vintage Space, where she discusses the Apollo missions at great length. Now, Amy and I do not see eye to eye on the narrative of the Apollo mission, but we're both historians, I like to think, and Amy did mention that Dr. Van Allen had given this advice to NASA. When I first, read that, I mean, Amy assures us that NASA didn't act on it, and that's not why they were bombing the atmosphere with nuclear bombs. But I had already reached the conclusion before listening to Amy on that subject that that's exactly what they were doing. And this is why. One of the effects of the nuclear bomb that you're maybe aware of is that the car stops. That's the first thing that happens. Your car stops if you're driving along the road. And it turns out that all electromagnetic fields are downed by the nuclear blast because of an effect called an electric magnetic pulse, which, is probably what they were trying to do. They were trying to shut off in the stratosphere with a big enough bomb, shut off the magnetic field of the planet. Okay, at this point, I would like to introduce to you a different idea which I've had, which, you can package it away with my ideas about the surface of the moon never being dark. And that is an idea I've had about the origin of the Earth's magnetism. So today you can research this, and you will find most people telling you that, or most of the research out there is based on the idea that Earth's magnetism originates from the planet itself, and it's to do with the convection currents deep down under our feet. But what I suggest is that what's happening is the Earth is basically just being like a big lump of iron, and the solar wind that is and the CMEs, the coronal mass ejections that pass by the Earth, they have a magnetic polarity, and I would like to refer you, and I'll leave a link to this SOL, the Solar Observatory Laboratory is it Pasadena in the US? It might not be Pasadena, but I'm pretty sure it's California. And the stellar work that those guys do, and there's a great YouTube piece available that I definitely will leave a link to down below. Please watch it. If you've got time, you'll really enjoy it. It's a great piece. And one of the things they say in that is they map the magnetism of each coronal mass ejection as it heads towards Earth. So my contention is that magnetic field constantly, over the eons, passing and rubbing by Earth is what generates our magnetism, And that just, to me, it's going to take a lot for me to be convinced that something that's happening down below us, where, remember, it's hot down there. So that's something that kills a magnet. If you've got like a permanent magnet and you leave it on the radiator, you'll find that it's lost a lot of its energy, because heat does that to magnets. So I can't really see how the very hot core of the Earth has really got much to do with magnetic fields in that way. That's just my idea, but if it's true, if it does turn out that the magnetism's got to do with, it's kind of now a permanent magnet, it was never going to be turned off with an EMP, because they only work, as far as I'm aware, with electromagnets. So, and I'm pretty convinced that is actually the case, although I do need to investigate that point. So that probably is something that, yeah, a little bit of research. Anyway, they didn't turn off the electromagnetic field. I mean, that was the upshot of the whole thing. So they weren't going to go into space. And in 1962, they knew that. Dr. James Van Allen knew that. But what he said was, all along, what is the point of sending people to space? You know, what is the point of sending people onto the moon? How are you going to advance science or exploration or discovery by sending people onto the moon? And, you know, this is one of these things where it's in people's minds that it was a scientific mission until they ask themselves the question, was it a scientific mission? And then the answer is quite clearly, even, you know, you can ask Neil deGrasse Tyson, who is a great champion of NASA and the Apollo missions, and he'll tell you, no, it's not a scientific mission. He'll say it's a propaganda mission. There's a Cold War. The space race is on. I don't buy that narrative. You know, I studied the Cold War a little bit at university, and one of the things that became clear and salient at that point was that, you know, not 1 acre of land changed hands during all the Cold War, which is incredible, really. They had a bit of a wandering of the 39th parallel in a little island called Korea, but throughout the rest of the globe, you had communist forces supposedly at odds with the forces of freedom, you know. And there was no actual conflict. It was a deal that was done in Potsdam in 1945 between Churchill, Roosevelt, Stalin, and nothing to do with the rest of us, the people. Nobody representing us, just the heads of these power blocks. So anyway, they were colluding. Of course they were, you know, with each other, against us. The USSR was amazed at the probable... I'm not going to go into all this. I just want to say that this terrible blunder of bombing the stratosphere created its own radiation belt, which is still there today and has recently been detected by a research group who were looking for it, you know. And the reason it wasn't detected prior to this in recent history is because nobody was looking for it, but they were looking for it, so they found it. And that's often the case in science, you know. Things won't be found unless they're looked for, and it's easier to not have to answer awkward questions about something just by basically ignoring it. Yeah, anyway, I'm sorry, I don't really know what I was referring to there in particular, but and I might even try and cut a piece of the video, but I think it is worth saying that well, you won't get a lot of research groups proving that Apollo never happened, you know, because who's going to back that? If you're a scientist working in the mainstream today, there's a good chance that you have something to do with the United States government or with NASA, even if you don't realise how it's directly involved in your institution that you're coming from, or you know, layers of research that you do depend on. Anyway, as far as astronomers are concerned, I mean, they've got more reason than most, as far as branches of as scientists, you know, to wonder whether the Apollo mission happened or not. I'll just point out that the original remit of Apollo did have an astronomical aspect, which has been resubmitted today for launching a mission to the moon, again, a manned mission to the moon. You know, I mean, I don't see why they have to have a manned mission to put a satellite on the moon, but they want a manned mission. And they've offered that as one of the reasons. And they didn't do it last time, so why should they do it this time? All we got in the way of a telescope and stellar photography last time was just an awful image from Apollo 17 that was done with something called a UV telescope, and it was an image that could have been captured much more clearly from planet Earth. It showed nothing apart from how useless the so-called scientists on the Apollo missions were. There was only one scientist actually ever flew to the moon, according to the claims of NASA, and he was a geologist who went with Apollo 17. None of the rest, all the rest of the guys, you were all soldiers basically, because, and sworn to secrecy and to obedience and to hold the line, They were all soldiers because they all were test pilots who had been in the Navy, or the RAF, or whatever they call it in the States. But everybody who's in the forces is basically, at the end of the day, he's a soldier and he's bound by the laws pertaining to soldiers, all the mores and the discipline. And so we don't expect them to come out and tell us that the whole thing was a hoax anytime soon. Why would they? I don't expect them to. Anyway, so I'm getting really far off the point here. I hope you don't mind too much and you haven't switched off. I'm trying to figure out where I am now. So, yeah, 1962, Starfish Prime failed, but they went ahead with the mission anyway. So, by 1969, one of the things that gets me, even by then, they seem to have forgotten completely about the light show of 1962. And today, I talk to people who are of 70, 80, 90 years old, and I ask them, do you remember 1962? Do you remember the light show, the auroras? Is it no? No? I don't know what you're talking about. So, and also I feel that this is getting, it's like, George Orwell's 1984. There will be publications that come up now and again that have been redacted and that have been cut, like even the stuff that happened before Apollo, to control the public and public opinion. So if you have any examples of that, I'd be very grateful to hear them. I'd be very grateful any advice that you might have as far as how I can get my message out, if you think it's worth sharing, and encourage me to be more academically rigorous and offer more references about what it is that you feel you'd like more hard evidence of these claims that I'm making, which are very much at odds with what it is that most people view the world to be, and what is even taught at all levels of academic excellence. Academic achievement. Okay, well, thanks everybody for listening, if you're still tuned in, and enjoy yourselves.